In this topic, we will look at the steps to balance a chemical equation. Step 1. Write the equation in the word form by writing names of reactants and products. The reactants are written on left-hand side of the arrow and products on right-hand side. In case the question already has provided the symbols and formulae, step 1 can be skipped and we go to step 2 directly. Iron plus steam reacting to form magnetic iron oxide plus hydrogen. Step 2. Write the skeletal chemical equation using the symbols of and formulae of the reactants and products. Step 3. List the total number of atoms of each element on both the sides. In the table, we see that the number of atoms of iron and oxygen is not the same in LHS and RHS of the equation. This indicates that we need to balance the equation by adjusting the number of molecules of those atoms which are not equal, and start step 3 again. Step 4. Continue balancing by using hit and trial method. Step 5. Check the correctness of the balanced equation. We see in the second table that the number of atoms of iron, hydrogen, and oxygen is same in LHS and RHS of the equation. Thus the equation is now balanced. In this topic, we have seen the steps to balance a chemical equation. It is advised that this is practiced. Also, there could be other ways to balance equations, and if you are comfortable in any other method, please feel free to follow that. Any method is fine as long as you are able to balance the equation.
In this topic, we will try to clear some basic concepts on how to count atoms in the molecules of the equation. Let's take a closer look at how atoms should be counted in the equation. We will look at aluminium sulfate, which is a reasonably complicated molecule. In the sulfate ion, there are 4 oxygen atoms and 1 sulfur atom. So, when there are 3 such ions in aluminium sulfate, the total number of sulfur atoms becomes 3 and number of oxygen atoms become 4 times 3, which is 12. Thus one molecule of aluminium sulfate has 2 atoms of aluminium, 3 atoms of sulfur and 12 atoms of oxygen. So, if we get an equation where 3 molecules of aluminium sulfate are present, all these get multiplied by 3. Thus we would have 6 atoms of aluminium, 9 atoms of sulfur and 36 atoms of oxygen in that equation. Let's take another example of ammonium sulfate. As we look into the ammonium ion, there is 1 nitrogen atom and 4 hydrogen atoms in each ion of ammonium, and there are 2 such ammonium ions in 1 molecule of ammonium sulfate. So, there would be 2 nitrogen atoms and 8 hydrogen atoms in each molecule of ammonium sulfate. Moving on to the sulfate ion, as seen in the previous example, there are 4 oxygen atoms and 1 sulfur atom in each molecule, and there is 1 sulfate ion in the ammonium sulfate molecule. Hence the number of atoms of each element in 1 molecule of ammonium sulfate becomes as follows: nitrogen 2, hydrogen 8, sulfur 1, oxygen 4. So, if we get an equation where 3 molecules of ammonium sulfate are present, all these get multiplied by 3. Thus we would have the following in that equation: nitrogen 6, hydrogen 24, sulfur 3, oxygen 12. In this topic, we have seen how to count the number of atoms present in molecules. In this topic, we will look at what other information is provided by balanced chemical equations. Balanced equations give the quantitative relationships between various reactants and products. This can be in terms of number of molecules, number of moles, relative masses, relative volumes of gases. This is called stoichiometry. For the purpose of explanation, we take a look at a simple equation where a water molecule is decomposed to hydrogen and oxygen. We can look at the number of molecules of reactants and products. 2 molecules of water dissociate to form 2 molecules of hydrogen, and 1 molecule of oxygen. In terms of the number of moles of reactants and products, we see that 2 moles of water dissociate to form 2 moles of hydrogen, and 1 mole of oxygen. In order to look at this equation in terms of relative masses of reactants and products, we need to first calculate the relative masses of reactants and products, as shown in the table. Thus, we see that 36 grams of water dissociates to form 4 grams of hydrogen and 32 grams of oxygen. Relative volume of the gases in the reaction. 1 mole of any gas has a volume of 22.4 liters at STP. STP stands for standard temperature and pressure, and it denotes the conditions of 0 degrees Celsius temperature, 1 atmosphere pressure. Thus 36 grams of water dissociates to form 44.8 liters of hydrogen and 22.4 liters of oxygen at STP. In this topic, we have seen how a balanced chemical equation provides information about quantitative relationships between various reactants and products, in terms of number of molecules, number of moles, relative masses, relative volumes of gases,